He has a master's degree in environmental health from Harvard University and a master's and a PhD in physiology and pharmacology from Southern Illinois University. And he has a special interest in marine biology, experimental gastroenterology, and the history of medicine. So, Dr. Pfeiffer, you have a presentation on spontaneous tumorgenesis in the newt.
Thank you very much. Good morning, ladies and gentlemen. Before I start, I want to make a word of appreciation to all of you. I know that the official organizers will be thanking you many times through this conference, but as one of the in-house faculty members here, I wanted to also express my thanks to all of you for coming here. This is a great opportunity for us to meet you and listen to your excellent presentation. So it's a big thrill for us in-house people here to have you all here in Blacksburg. I'm going to be speaking about spontaneous tumorgenesis in the Japanese newt, Synops pyrogaster, and I thought before going into this specific topic I should make some general comments also about this species because it may not be all that familiar to many of you. Many of the species under discussion in this symposium relate to animals of significant commercial importance, the salmonoids and farm fish and so on. So you may be wondering why this strange newt is a topic of discussion. It's not the most popular animal in this country. You will occasionally find them under the name fire newt in some of the pet stores sometimes. It's not even a big seller there. But in recent years it's been a subject of a lot of experimental investigation, partly related to a viral-induced tumor of the skin, and it's become quite a good model for study of viral induction of carcinogenesis, and it's of interest in some other studies that have been done with them. I'll mention a few of these as we go along. Later this year, this species is going to become very famous. July 8th, you can mark that on your calendar. There's a space shuttle going up with an experiment that we have on board with this species. I'll comment on that a little bit later at the close of this. But at that time, everyone will know about the Japanese newt, perhaps. But at least at the end of this morning, you'll all know about it. The name Synops pyrogaster is not the oldest name for this species. It was formerly called Triturus pyrogaster. This refers to fire stomach. It's very brightly colored red on the stomach, a beautiful animal on the ventral aspect. So the name was changed to Synops some years ago. So you're probably familiar with other Triturus species which are used in research, which are distinct from this one. As the name implies, this is from Japan. We get our animals flown to us from Japan. They're quite numerous in that country. I understand they're present also in mainland China. I have never seen any publications or references to them in China, but I believe that they're also present on the continent there. I should mention something about how we began to work with the species and why they are of interest to us. And this dates back to about 1976, I think. At that time, I was working in Canada and contemplating a year's work at Kyoto University at the First Department of Surgery at the medical school there in Japan. And before leaving, I ran across a very obscure journal with a nice article about the species from Japan. And it gave reference to the fact that this species is good for immunologic studies, that they tolerate surgery very well, and a very rugged species with some prospects for experimental studies. So when I went to Japan, where I was working for a year, mainly with rats and cats in GI studies, I thought I'd get some of these animals and do some GI studies on them. Most of the Urodel amphibia, as you are well aware, have a great potential for regeneration of tails or amputated limbs and so on, more so than the anurin variety of amphibia. So I thought that we could do some amputations and deletions and so on of the gut of this species to see if they would regenerate parts of the gut. So we did some microsurgery and did some hemigastrectomies with them. And we did find indeed that they tolerate surgery very well. They were highly resistant to infection. They never had any infectious disease problems that we were aware of. We lost almost no animals due to this major surgery, so they tolerated that very well. Unfortunately, they didn't regenerate the stomach or intestinal parts that we resected. But we noticed in the course of this work that these animals had a papilloma on the skin. This was a non-pigmented, frequently large papilloma, and so we paid a little more attention to this papilloma. We later found in the literature that there were two references, more or less single case histories of this papilloma on the species, and but we found that they were rather numerous, so we studied them, and this, by the way, is the, turn down the lights so you can, oh, thank you. This is what the animal looks like. It's a small newt, just about 5 inches long or so, dorsal side and ventral side, and hence the name pyrogaster. Each animal is a little bit different on the ventral side. The design is a little bit different, and some of them have a little yellow mixed in the coloration. There is a I'll give some general comments about this species. There is some sexual dimorphism. This one here is a female. The males are slightly smaller. The head shape is a little bit expanded in this zone here. The males have a higher tail from the dorsal to ventral aspect, and but other than that, they're similar. Also, some general comments about this animal. The longevity is not very well known. It's estimated they'll live to be about 15 years of age. They have been kept in captivity for 10 years for the same animal. As you know, with other captive wildlife species, the age reached in captivity is not necessarily representative of what would be found in the wild, but it's somewhere between 10 and 15 years. Anyway, this is what they look like. And they're easily maintained, and I'll later make some comments at the conclusion of this about maintenance and so on in case you wish to do work with this animal. Well, the papilloma that I was referring to that we discovered in Kyoto was rather common, and it was present in about 3% of the animals. So much of what I'll say later this morning will focus in on that papilloma. Nonetheless, other studies have been done to acquaint you generally with this species over the years. On your handout in the booklet that was given to you, there's a list of references summarizing most of these articles. There's a few more not listed there and some in press, but they will summarize a lot of the work that's been done with this species. Some study has been done characterizing the hematology of this animal. I'm not going to go into details on that. The basophil, such as one shown here, is one of the prominent, probably most important white cell in this animal. Other studies have been done with this species. One series of studies, many of these studies have been done in conjunction with Professor Makoto Asashima, who is head professor at the Department of Biology at Tokyo University for the last year. Formerly, he was doing work with Newts at Yokohama City University. He formed a connection with the Japanese Institute for Space and Aeronautical Sciences, and on site there at Sagimahara in Japan, north of Tokyo, 1 hour, where the Space Institute is located, they have this chamber right here, which is a walk-in chamber, which shields out background magnetic field. So the magnetic field strength inside this chamber is about 1/10,000th of that present the surface of the Earth in an unprotected area. So one line of work done with this species has been done in here to study development, early development and embryogenesis in this newt, shielded from external magnetic field. And it was found, as shown here, in some of the general background information on the species, that the percent abnormal embryos increases when background magnetic field is eliminated. Developmental stages are shown here, and the solid lines in the histogram show percent of abnormal embryos, which increase in most of these different stages during the presence of shielding. I'm not going to go into a lot of detail of a lot of these background things. This is sort of a quickie overview of some of these other studies with this species. Those background changes included the abnormalities, by the way, things such as biheadedness, protruding gut abnormalities, and curvature of the spine and developmental defects like that. Other studies with this species have included cardiac studies in which the structure and ultrastructure of the heart was examined. Here's the trabeculated heart, and shown ultrastructurally here. Endocardium has been studied, and all aspects of the heart has been studied, including development. Hearts of this species have been cultured for long periods of time, in excess of 280 days. They continue to beat through this time. At the very end of the culture period, the beat drops down to maybe 1 beat per minute. The development, especially in the early stages, looks like the same development in an intact animal. The beats are temperature dependent, as you would guess, as shown here. Increasing beats with increasing temperature. So these cardiac studies have been done also with the newt. Regeneration studies have been done with this species. Here's a normal cleared view of the forelimb, which the bones have been selectively stained. And here's one in which it was amputated here. And we have studied, since we'll be getting into tumorgenesis in a few moments, we have studied the effect of exogenous mutagenic carcinogenic agents to these animals and how that may affect regeneration of the limb. In this particular line of work, we examined 3 different drugs, including MNNG, N-methyl and nitrosoguanidine, which is a common carcinogen with high site specificity for inducing gastric cancer in most species, including most mammals, and some other carcinogenic agents, all of which enhanced the incidence of abnormal developing limbs in animals that were previously amputated. Hepatic studies have been done with this animal. They have a large liver. Here's a liver the size that you would get from an animal like this. The hepatocytes themselves are pretty conventional looking, but there is an interesting other cell that's present in the liver, which is this type of cell here, which has a somewhat obscure function. I won't go into the details of this cell type. It's referred to as the OC cell. Yesterday, with respect to some fish, you've heard of the melanomacrophage, which looks a little bit similar to this. There may be some relationship, or there probably is some relationship to melanin metabolism in this cell type, but this is apparently not a melanomacrophage. There is no evidence of macrophage activity. In the liver of the species, also one does not observe typical Kupffer cells. The granules within this cell type, as shown in this slide here, are complex, and they contain within each granule subparticles. And these granules, by the way, are very dissimilar from melanosomes, melanin granules, which are present in well-established, well-known melanocytes, for example, in the skin of this same species. And also the shape of the cell is very distinct. So they certainly, if they are melanin, it's rather distinct from the typical melanocyte in the same species. So we will have to wait for some future studies to clarify the chemistry and the role of this particular cell type. Now we're moving into the skin, which is the main thing I'd like to talk about. The skin of this animal is quite interesting, even the normal skin, without the presence of these papilloma, is quite interesting. We're currently still studying the skin, and there are some quite interesting complex glands in the skin. To some extent, mucus is secreted, as it is in other amphibia. But there are other components secreted which are less understood. There are some highly volatile, probably quite toxic chemicals secreted on the skin of the Japanese newt. I believe that this is probably a defense mechanism. Other amphibia, as you know, secrete a lot of toxic agents on their skin, including some of the frogs, which are secreting extremely highly toxic compounds the Indians use for inducing paralysis and so on. You may be aware of the Oregon newt in this country that secretes tetrodotoxin on its skin. There have been a couple of human fatalities, fatal initiation rites for fraternities where a couple of people have swallowed live Oregon newts and died as a result of this. I think in the case of the Japanese newt, a protective defense mechanism is excretion of some unknown compound which prevents predators from eating this animal. Most animals will reject this animal in the water, and it seems to be a waterborne toxicant. Anyway, this is normal skin showing the epidermis and the dermis down here with the glands residing in the dermis. As you can see, the skin is fairly thin, only several cells thick. There's an outer stratum corneum and a stratum granulosum, and beneath that you can see a layer of melanocytes, pigment cells, and they contribute to the black color of this species. But this is just a typical normal skin of the Japanese newt. At higher magnification, oops. See if I can get a better focus on that. Probably not too good. By scanning in electron microscopy, there are various folds that are evident and some little tubules present on the surface of the skin. This is all normal skin. And these tuberosities here seem to represent where the openings to some secretory glands will be found. And at higher magnification, you can see some of these openings here. And as we keep increasing the magnification, you can see another opening here to one of these glands. This is the boundary of one epithelial cell on the epidermis. Here's another boundary to another one. And as we keep increasing the magnification, here once again is the opening to one of those secretory glands. And you can begin to see a finer structure now on the surface of this one cell. These are actually micro-ridges, which are shown here. A little bit blurry. At higher magnification, these ridges in cross-section by transmission electron microscopy appear as small stubby microvilli. But that's misleading, and that's one of the advantages of scanning electron microscopy, because you can see they're not microvilli, they're actually ridges. These cell surfaces are very similar to those you have probably already seen in several species of fish, and even we've seen similar surface on the baleen of mysticete whales, for example, the same surface type to the cells of baleen. So it's a general cell surface enhancement for surface area. In cross-section at the same magnification as the previous slide, you can see one of these glands in the normal skin of the Japanese newt. And I might say, to make it one generalization, the normal skin of the Japanese newt seems to be rather more similar to teleost skin than it does to skin of some of the other amphibia that have been, sorry. There we go. Some of the other amphibia that have been reported in the literature. At this point now, I'd like to turn into the tumor, specifically the papilloma, or sometimes referred to as the epithelioma, present on this species. As I mentioned earlier, we found these things just by accident in our laboratory in Kyoto on supposedly normal newts. So we pursued it further, and we wanted to find, first of all, the incidence of this newt. So we obtained animals from some local supplier in Japan who provided us with some of the animals, but we needed larger numbers, so we finally had to go out to the field and catch them ourselves. And these animals reside normally in the rice paddies and ponds and streams around all of Japan, throughout the entire island. Generally, they live in the water entirely. Like other amphibia that are sometimes on the land, these animals tend not to crawl out very often on the shore. In the laboratory here at Virginia Tech, we keep them in aquaria, and I put little floating raft, and sometimes they crawl out on that, but usually they stay in the water. In the cold season, in the wild, they will congregate, and in fact, when we captured them in the wild, we would go to farmhouses where they had some wells, which were a little bit warmer, and you could actually go to these well areas and scoop out literally hundreds of these animals. So they're very easy to collect in the winter season. So that enabled us to get quite a few to study this tumor. Generally speaking, spontaneous tumors in the tailed amphibia, Urodela, are not so commonly reported in the literature. In this species, a epithelial tumor was reported in one quite old case report. Lymphosarcoma was found in the same species in 1954. It was transplantable. In the axolot, melanomas were seen, but very uncommonly, only 8 over a 30-year period by that particular worker. Professor Zavanellia of Italy, resides in the Milano area, which is contaminated with a lot of industrial and other contaminants. And she collects the crested newt from the wild in that region. She found a high incidence of cutaneous melanomas in newts which were exposed to a lot of pesticides in the environment. And she found that these melanomas would metastasize to the small intestine and liver. As shown here is a metastasis growing in one of the crested newts in Italy. But in reviewing all the literature, which was done in this case by my colleague, Professor Asashima, who did this a few years ago, 1986, 491 cases of spontaneous tumors were found in the literature in 18 species of the anurans, the non-tailed adult amphibians such as frogs, and fewer, such as 253 cases reported in only 12 species of urodales. In all likelihood, the natural incidence is higher than this. Generally speaking, a lot of the people, a lot of the biologists, for example, working with these animals in the field and so on, do not do careful necropsies of the entire animal. So in all likelihood, there are tumors internally present which are just simply not detected. And if the incidence is low anyway, you would have to really appraise quite a few to actually find them. Of course, in the wild, sick animals would also just die naturally or be caught by predators and so on. So the true incidence is probably higher than this, but nonetheless, in the literature, they are not really that common for the urodales. Detailed, numerous scientific reports are even less numerous, and they have been mainly focused on a few species. The rather famous leukorenal adenocarcinoma is probably quite familiar to you. This is in the Rhaenopipians, the leopard frog, found in this country. A lot of the work was done with frogs captured in Minnesota. They found a seasonal difference in the spontaneous adenocarcinoma. They occurred mostly in the fall and in the spring seasons. Those studies that were done back in the 70s focused on this tumor. It received a lot of publicity then. In later years, people have gone back and caught these animals. Thousands of them have been caught and appraised. And the incidence seems to be dropping way, way down, so that nobody reports it anymore. And in the wild, this tumor has almost disappeared. So there's a change then that's unexplained. And as I say, there was a seasonal variation in that tumor. In the Japanese papilloma that we have been interested in, there is also a seasonal variation. The incidence is highest in the autumn. It's perhaps 4 times greater than it is in any other season throughout the year. A second type of tumor that has been most studied in amphibia are melanomas and neuromas in the African clawed frog. And I might mention there's a new exciting tumor recently discovered. I was working for 3 months recently in Kobe, Japan, and I talked with the cancer specialists in Tokyo then, and with the same species here, they have discovered a pancreatic tumor, and they have identified unusually an RNA virus responsible for that pancreatic tumor, which was highly invasive and quite a bad tumor for that species. That was about 5 months ago. It was not in the literature yet. It was going to be reported at the cancer meeting in Japan, so it's quite possibly it still is not out in the literature. But anyway, with this species here, there's still one more spontaneous tumor of significant interest. And lastly, the epithelioma of the Japanese newt as the other one that's most studied at this point. This epithelioma as I said, was rather common. It is, at this time, we're quite sure, caused by a virus, which we have seen. In the same species here, Cyanus pyrogaster, some other tumors occasionally have been reported. One of these is one that we worked up a study on. A leiomyoma was found in this animal. Of 700 newts that were studied, 19 of them had a leiomyoma. It was sharply circumscribed. It was in the muscularis externus smooth muscle. Seemed not to be too harmful to the animals. This was reported not so long ago in Journal of Comparative Pathology. And here's a picture right here of one of those tumors on the surface of the stomach. Right there. This is not the best slide in the world, but here's the animal's foot, and there's his skin. Here's the stomach, and there's the tumor, two pieces of the tumor right there. And in cross-section, here's a bit of that leiomyoma. Now the papilloma, or epithelioma, is the main one I'd like to talk about, and here's a picture of one of them. This one is quite large. It's relatively non-pigmented, and in our laboratory in Kyoto we found that these tumors had a remarkable ability to regress spontaneously. So this was of a lot of interest if we could find out, for example, why they regressed. I have in your handout, I believe there's the photo that I just showed previously, and a later stage, a few weeks later, the same tumor was shown after regression, very much smaller size. Here's another illustration of a papilloma right there, same type on the ventral surface. Here's one also on the ventral surface, one on the digit. And occasionally, under somewhat rare instances, these will be found at multiple sites. We refer to them as simply as polypapillomatosis. And these animals seem to have a weakened resistance, and multiple tumors will be found. This looks quite severe. As you can see, here's another animal. And remarkably, these tumors, even in situations like this, do not seem to really impair the animal. It goes on living. We've kept them a long time in the laboratory. They feed normally, behave normally. So these are superficial tumors. They seem not to be invasive and not really life-threatening to the animal. The initial study we did when I was in Japan was based on 1,586 newts, of which 44 had tumors spontaneously. 13 had multiple tumors, but in those cases they were usually maybe 2 or 3 sites. They were not the severe polypapillomatosis that I showed you a few minutes ago. So the incidence rate was about 2.7%. Males and females were more or less equally affected. This was followed up a lot more carefully and better done by Professor Ashishima, who looked at about, I think it was 5,238 newts, and he looked at them from different regions and in different seasons. And he found that the rate of incidence varied from about 6 down to about 2%. Depending upon the season and the location. And geographically, on the west side and the northern aspect of Japan, the incidence was a lot higher. As I mentioned earlier, the autumn season was the peak time for the high incidence. He also found a comparable incidence both in males and in females. This is a cross-section showing the tumor. You can see that there's a great deal of hyperplasia. You can see there's, for the most part, disappearance of that basal layer of melanocytes shown in the normal skin. Here's some remnants of melanocytes there. Going back to the normal skin, to refresh your memory, you can see the normal skin does not have that hyperplasia and does have the underlying melanocytes. These tumors, then here's another section showing one, and the lack of melanocytes underneath. The protein composition of the skin was examined in tumors, comparing them with normal skin. And it was found by two-dimensional gel electrophoresis that normal skin had 9 protein-specific spots which could be identified, which were not found in the tumor gels. Here's it's sort of hard to compare these when you just see them one at a time. Here's a reference actin protein that was run in the test. And this shows some of the this is normal skin gel here showing protein spots specific for normal animals. Here's one from a tumor. And it was also found that the tumor tissue had 3 specific protein spots specific for the tumor. It could be that those protein-specific spots may have represented something from the virus itself, a virus protein perhaps. The tumor incidence was checked with respect to environmental temperature, because it was thought that maybe they regressed in the laboratory condition because of a temperature change. And one of the nice things about working with cold-blooded poikilothermic animals is you can manipulate the temperature, the animal remains normal, and you can see nicely a temperature effect. It turns out that these papillomas have peak occurrence at a moderate temperature of about 10 to 13 degrees centigrade. And as you increase the temperature, say up to 25 degrees centigrade, the tumor incidence goes down and they regress. As you cool down the temperature, for example, to 4 or 5 degrees centigrade, once again, the tumor incidence goes down and the existing tumors regress in size. So there's a temperature dependence of them. The protein spots, when these animals with tumors are placed under those conditions where tumors would regress, that is the low or the high elevated temperature, the normal skin protein spots determined by gel electrophoresis will start to reappear after a few weeks. Relating this to the environmental natural condition of the species, then you may point out that perhaps the incidence is high spontaneously in the autumn, and as winter comes, it gets colder, and the temperature is responsible perhaps for killing the virus, and the tumor incidence goes down. That seems to be one of the factors, but it is not the only factor, as I will mention shortly. Another factor seems to be ultraviolet irradiation. It was hypothesized that in Japan, the exposure to ultraviolet irradiation may be different in the high and low risk areas for this tumor. And the meteorological records were checked in Japan. The days of sunlight versus overcast days were rather different in the high and low incidence areas. The overcast areas would shield out perhaps some of the ultraviolet light, and if that has an effect on the tumor, that might play a role in tumor incidence. We tested this experimentally by experimentally exposing newts with tumors to rigged up ultraviolet irradiation. We used germicidal lamps as the ultraviolet emitters. We placed the lamp 30 centimeters from the aquarium, controlled conditions. In some cases there was 10 centimeters of water, in some cases no water in which the newts were exposed. And I'll give you the details of the experiment in a moment, but anyway, the exposure to the appropriate ultraviolet light exposure would cause these tumors to regress. Here's a slide showing normal control skin, a non-exposed hyperplastic papilloma. After exposure, the tumors regressed. There was vacuolization in the hyperplastic region. There were also some zones here, like the arrow pointing, little focal necrotic spots of degeneration. This slide you have to lay down to look at, but anyway, looking at to find the correct exposure of ultraviolet irradiation, 3 different doses were used. The higher doses, which we ended up not using, did cause some fatalities. The black squares are dead animals. The open squares are living animals. And at the most high exposure of ultraviolet irradiation, which could be measured by its flux meter, caused too many fatalities. A lower dose caused some. And this lowest dose of ultraviolet radiation caused no fatalities in normal animals. So this is the dose of radiation, which is not actually listed there, which we used for those experiments. Showing the percent change in size of these tumors, non-exposed control animals, the tumors remain the same size. Those which were exposed in the water had decreasing size of tumors, and those animals which were exposed to ultraviolet radiation out of the water had a similar decrease in tumor size. So from all of that, we would conclude that probably one of the other factors in the natural environment which perhaps may modulate the tumor incidence may be exposure to ultraviolet light, which was rather different across the length of Japan, maybe another natural factor controlling it. This is just a reminder of the last thing in closing. This project that's starting this July is called Newt. Professor Ashishima is the principal investigator of this project. I'm helping him a little bit with it. Anyway, the team there from Japan is going to Cape Kennedy this July, and this is an international cooperative space shuttle, and this one involves, for example, a Japanese lady surgeon, I believe she is, who will be an astronaut who will be manipulating this experiment. And that particular experiment is focused on early embryogenesis and the effect of prolonged weightlessness, in this case for 2 weeks of weightlessness, on early development of this species. So the little Japanese newt is moved from the tumor field now to outer space coming up pretty soon. So that's all I had to say in summarizing this tumor. And any questions you might have, we have a few minutes. I'd be happy to answer any questions. Thank you.